Acceleration is where I heard people started getting confused in physics. But anyways, this will be like the conceptual part of acceleration. If you're looking for like how to like calculate it or like how to read a graph of like acceleration versus time, then this is not the right place for you. There's going to be a video up on that soon. Anyways, let's get into acceleration. So acceleration is defined as a rate of change of velocity. And from our previous video, we learned that velocity is the rate of change of position. So acceleration is like velocity, but for velocity. You can think about it this way, right? So let's say that you're in a car driving at 40 miles per hour, and then you like decide to speed up. Then you like go to 50 miles per hour. From 40 miles per hour to 50 miles per hour, you had to like accelerate. Like you had to change the rate at which you were moving. That rate of change is acceleration. It's like the same thing in the other direction. Like if you were first traveling at 40 miles per hour and then you slowed down to 30 miles per hour, then that means that your acceleration has changed in order to get to that point. There's like this whole like acceleration and deceleration thing. So in a non-physics context, deceleration is just like slowing down. But in a physics context, deceleration is just negative acceleration. And you're gonna think, isn't that the same thing? Not really. So deceleration in a physics context doesn't necessarily mean that it's slowing down. Like this object can start traveling in the negative direction. Like let's say that I had a car going at 40 miles per hour in a positive direction, and if you don't understand this whole positive and negative thing, I did go over it in the velocity and speed like video, but we can do an individual video on that if people still don't understand what I mean by it. But back to our example, if it's going at 40 miles per hour in the positive direction, and then it like makes a U-turn and starts going at 50 miles per hour in like the other direction, which is known as the negative direction, that car technically didn't slow down. Like it's going even faster, but it's technically decelerated because it's going in a negative direction. Anyways, back to the PowerPoint. So acceleration is typically depicted as A. Just the letter A. Units are meters per second squared, which makes sense, right? Because it's like the rate at which velocity is changing, and velocity is measured in meters per second. And then average acceleration. So once again, like this is like average velocity. We're gonna look more into like instantaneous acceleration. Like at this point, a falling object was accelerating at 9.8 meters per second squared. That's its instantaneous acceleration. So in this case, average acceleration is basically like average velocity. I'm taking the change of velocity of the entire thing and dividing it by time. So let's say at point 1, an object was like moving at 3 meters per second, and then in 2, an object was moving at like 4 meters per second. The change of velocity is 1 meter per second in that scenario. Then you're going to divide it by the time. So let's say that time is 2 seconds. Then your acceleration, your average acceleration is 0.5 meters per second squared. Alright, that should wrap up this video. Cass, cut out like that middle part. I don't know what happened.